Hello everyone. Good afternoon everyone. Or some of the side have good evening as well. Good evening guys. Hope I'm audible for everyone clearly. Can you guys clearly? Am I audible clearly for everyone? Okay. Yes, there was a no assignment for yesterday. Let me share my screen, guys. Let's just discuss the what we have done. Let me share my screen to all of you. Has anyone seen, like, can anyone see my screen now? Is my screen up for everyone? Okay, guys. Yes. Then let's just discuss. These are the quizzes we have shared on the day 3. We haven't discussed the thing yesterday. We forgot. So these are the quizzes we are going to discuss for today. Okay. Hope everyone basically done this kind of quizzes, right? These are the quizzes we have shared on the day 3. Shall we start, guys? And first of all, like, guys, for everyone, happy Holi, right? So we have a Holi for today. Okay, let's get started, guys. Okay, then after that, we will discuss what we have covered yesterday and all that stuff. So what type of machine learning algorithm makes predictions when you have a set of input data and you know the possible responses? So can anyone tell me what exactly it is? There are 4 options: supervised learning, supervisory logic, unsupervised learning, or deep learning. Can anyone tell me what exactly it is? I believe some of you has done. Yes, some of are saying supervised. Okay. Any more? Okay. Yes, this is called a supervised machine learning, basically used for that, where in supervised machine learning we have to provide a input data like the way we have done, right? We have done. What are the supervised models we have talked before, like linear regression, decision tree, random forest, these all the stuffs, right? We have covered these things previously. Okay, now when would you reduce the dimensions in your data? What exactly the meaning of dimensions? We know that, right? Dimensions basically mean where we reduce the size of the data, right? Let's suppose I have a data which has basically 100 columns, and we know that 100 columns cannot be used, or like 100 columns would not be used for my predictions. That is why I have to reduce the dimensions, right? So when would you reduce the dimensions in your data? When the data comes from sensors, when you are using a Linux machine, when your data set is larger than 500 GB, okay, when you have a large set of features with similar characteristics. D option. Yes, there is a D option. So guys, don't basically, like, don't, these are the quizzes, don't take it in this way like we are kind of a solution and all that stuff. These are the questions I have made up for you to basically for understanding purpose, right? What exactly these are the, so we have talked already, right? Using principal component analysis. Yes, some of us saying PCA technique. There are many more techniques as well, but PCA is the famous one, right? So if we have a large dimensions of our data, so there at that time we have to reduce the dimensions of our data. The meaning of dimensions, basically we have to reduce the features. Features basically means the columns, right? Now what does a classification model do? Can anyone tell me what does a classification model do? What exactly the classification is? We know that, right? What is classification problem, right? And what are those models? Like decision tree, random forest, those are the models can solve a classification problem, right? So now can anyone tell me, it predicts a real number responses such as changes in temperature, date, or time. assigns data to a predefined category, cluster responses in groups based on similarity to find pattern, compares predicted data classifications to the actual class labels in the data. Yes, the option D, correct. Correct one. So basically classification model compares the predicted data. We know that, right? In linear regression, in classification problem, basically we have to predict, right? After the prediction, we have to compare those predictions to the actual data, right? To the actual class labels in the data, right? So don't worry about it. If you haven't understand these kind of stuff, what are these exactly, we will discuss these things later as well, but just try to understand classifications model. Those are the models which will basically predict a classes, right? Correct. Yes. Now, which one of these classification algorithms is easiest to start for prediction? Can anyone tell me which one of these classification algorithms is easiest? Neural network. Okay, some of us are saying neural network. Okay, anything else? Logistic, naive base. Okay, naive base. Okay, naive base. Yes, correct, guys. You can say naive base and logistic regression. Those are the model can be used for. There's a multiple quiz as well, right? There's multiple selection for this one. Naive base can be used for classification as well, and logistic can be used a classification as well. And either we can select a backed decision trees as well, right? We can choose a decision tree as well, because decision tree can also solve a classification problem. That is why. Yes. What does hyperparameter tuning do? What does hyperparameter tuning do, and when do we use it? Optimizing a parameter to improve performance of learning algorithm, specify the hyperplane that represents a linear classifier, expand the parameter, take parameter using a start degrades. Anyone? Anyone? Can anyone tell me? Option A. Okay, some of you are saying option A. Can we get some more responses? Okay, option A, yes. Optimizing a parameters to improve the performance of a learning algorithm. We know that hyperparameter tuning is a technique where we improve the model performance. Let's suppose my model is giving me 80% of an accuracy. So is there any technique where we can improve the performance of a model where I can get a 85, 90% of an accuracy? So there is a hyperparameter tuning do. Okay. Now, what is principal component analysis, PCA? Can we get some more options? Can we get some responses over there? Yes. What is exactly PCA? Anyone? Okay, option B. Some of us saying option B. Okay. Option B, option A. Some of you are saying option A, option B, option D as well. Okay. Okay, option B. Yes, the answer is option B. Basically, right, principal component analysis is an technique where we remove the features transformation technique for reducing a data dimensionality, right? For first A, it is basically adding. Here, the option A is also showing add and remove. No, we in PCA, we just only remove the features. Okay, now what exactly the overfitting problem is? We have discussed a sum of part of overfitting, right? What exactly the overfitting problem? Anyone? What exactly the overfitting problem is, guys? Okay. Option B, specify the training data that can be generalized to a larger data set. Okay, option B, some of you are saying option B. Is this option B is correct? Yes, there's an option B, correct. We know that overfitting problem, right? Wherever our machine learning model is performing better on a training data, but it is not performing on a test data, right? That's a simple one. We will discuss overfitting problem as well in depth as well. Okay, now let's just move ahead. Decision tree, also known as a cart. What exactly the cart is, right? There's a technique. Basically, decision tree uses a cart technique. What exactly it is? Okay, some of you are saying option A. Yes, classification and regression trees. Yes, correct. The full form of it is classification and regression trees. Yes. Decision tree can be used for classification, regression, both or none of these. Yes, option C, both of them. Yes. Regression tree, we know that decision tree is a model which can be used for classification or regression, both. Yes. Decision tree is a dash algorithm. What kind of algorithm it is? It is a supervised, unsupervised, or semi-supervised. What it is? Option A. Yes, that means it's a supervised learning algorithm. Correct. How do I stop overfitting problem in random forest? There's an option, 3 options over there only. How do I stop overfitting problem within a random forest? How do I stop? Option A. Okay. Predicts the data, probability, optimize the hyperparameter tuning. Option A, option B. Some of you are saying option A, some of you are saying option B. Can we get some more responses? And can we get option B? Okay. Some of you are saying option A. Okay. There's an option A or B. Can anyone tell me clearly what exactly it is? There's a last quiz as well. Okay, actually the answer is option B, where we basically bootstrap the data from the each tree. No. Yes, B is correct in this one. Correct. So these are the quizzes, guys. We have shared previously as well, right? On the day 3, right? Very well done for everyone. Now let's just discuss about today's one. What exactly today's one we are going to discuss? Okay. So previously, yesterday we have talked about these are the, so we have talked about we did some EDA part on our data. We know that, right? We know that we don't have a too much data. We don't have a big data, right? Okay, so we did yesterday EDA. We analyze our data. We have seen our data in the form of visualizations. We made a multiple charts like distribution plot, pie chart, right? And box plot, multiple charts we did yesterday. Okay. So there are 5 days of a workshop, guys, and this is the last day for a workshop. This is the 5th day, right? Now let's just start ahead. Okay, so the day 5. So as we have discussed, we have yesterday, we have understand the data. After understanding a data, we have seen some of the steps. First of all, we have to basically collect the data. Where we need to collect the data, there are multiple sources from the online, using APIs, from the SQL server, multiple ways we can collect the data. After the collecting a data, let's just discuss those steps first, right? Again. So step 1, basically collect the data in the form of Excel, CSV, JSON. These are the steps, right? After the next step, cleaning a data. The main aim of cleaning a data is to basically understand our data better, right? Or business knowledge, you can say the meaning of cleaning a data is, right? After that, EDA. To do some EDA to understand your data better, to see your data, how your data looks like, how redundant features do you have in your data, to showcase your manager, to showcase a person which don't know about exactly the code and all that, right? Which don't, like, that person know about the business only, right? In this way, feature engineering, remove features, scaling part, these are the stuffs. ML models. So now we will talk about these are the stuffs today only, right? So machine learning models like classification problem, or whether it is a regression problem. Predictions, evaluation matrices, what are those? Okay, now we'll discuss these are the stuffs today only. So now let's just deep dive today for the machine learning models ones. Okay, where we are this one. So we know that sklearn is a library which is basically used for machine learning models. We know that, right? We have discussed these stuffs. So sklearn.linear underscore model import linear regression. Import linear regression from sklearn.model selection. Import train test split. So this is the model, not model. These are the parameters. You can say these are the functions we have in Python. Basically, can help us to basically distribute your data. There's some 5 days of a workshop, guys, and there's a last day for one. Okay, so train test split, there's a model, there's a function in Python basically helps us to split our data. Okay, C1 is a library which is used for use of visualization. Matplotlib is a library for visualization. sklearn.matrices import a mean square error. What exactly the mean square error is? Some of you had heard about mean square error, right? Least square method as well. R value or R squared value in regression, right? In 10-12 standard as well, right? So basically, these are the matrices where we use to basically these are the matrices basically used for to calculate how our model is performing, right? The R square, mean square error, these are the matrices we have for regression problems. Let me just write here regression problems. If I'm going to solve any kind of a regression problem, at that time, what are those matrices I have to evaluate my metrics? So evaluate my model or evaluate my regression model, mean square error, R square value, right? These are the matrices we have. Or for classification problems, what are those matrices we have? What are those matrices we have for classification problems? Can anyone tell me if you have some idea what are those matrices we have for classification? F1 score, right? Some of you have known, I believe, or not. Don't worry about that. So the for this one, F1 score, accuracy, confusion matrix. Yes, confusion matrix. Confusion matrix. Recall, precision, multiple things we have for classification. So as I told, interviewer may ask most of the time, right? What are those matrices we have? Again, what are the matrices we have or evaluation matrices we have for classification problem? So you just need to tell them, okay, F1 score, accuracy, like confusion matrix, like some people are saying precision, yes, precision, recall, sensitivity, correct. These are the matrices we have to evaluate our model or a classification model. Okay, now we know that yesterday we have covered everything. We have basically collect the data, we have cleaned the data. Previously we have already cleaned data. So these are the steps I'm explaining again. Cleaning a data for understand the data better, EDA part, right? After that, feature engineering and all that stuff. Now the next step is to basically distribute your data in the form of machine learning model understandable format. Again, after that, the next step is to basically prepare your data or split your data in the form of machine learning model understandable format. We know that machine learning model can be learned throughout a data within the form of numerical format, within the form of numerical format, right? If we have a data, if in our data set we have some classification, or you can say our classes. Let's suppose in a data set somewhere is written Delhi, Mumbai, Bangalore, Chennai, in this way, right? Or string kind of a data, machine learning model cannot be learned. So we have to convert those data into the form of numerical format, right? So that means the basic idea behind it is to basically we have to convert our data into the form of numerical format always, because machine learning model or machine, basically you can say machine or computer can be understand a data in the form of numerical only. Okay, now what we are doing here, I'm just going to dropping these two columns throughout my data set. So we know that df is my data frame. Okay, let me just write it here now. For df is nothing but df dot head. What it is error? Okay, so it is showing me these are the data set we have. These are the okay, this is another data set we have trained on. Okay, no worries about it. We know that what exactly the data set we have yesterday, right? The another data set I have imported here. So see, my data set looks like looks like in this way, right? We know that country, library size, number of TV shows, in this way. We know that this kind of a data we have. Okay. Label encoder, we can use that, yes, for sure, to convert our data into the format of numerical. Or label encoding part, we generally called this technique is basically encoding. Okay. Yes, guys, we can use that thing. So we know that what kind of a data we have yesterday. Let's just remove this now. So these two columns I have dropped one hot encoding. Yes, one hot encoding. These are the encoding techniques we use for converting our categorical data into the form of numerical data for machine learning models. Okay. So what I'm doing here, I am basically dropping two columns, cost per month and country. These are the two columns I'm dropping off from my whole data set. DF is my data set, which contains 7 columns yesterday, right? And I'm going to drop off 2 columns. Why? Because country is my column. It's a basically it's a categorical data. It is my categorical data, and it is not helpful for me for my machine learning model, right? It cannot be much related. There's no much high, you can say, a strong relationship from my you can say target variable. That is why I'm dropping off this one. And why I'm dropping off a premium column as well? Because this is my target variable. This is my target variable. I have to predict, I want to predict what would be the premium, what would be the premium price of a Netflix, right? Or different countries or different platforms, whatever it is, right? Or axis one is basically nothing but column wise. I'm going to drop basically means I'm going to removing these two columns from the axis is equal to 1. Axis is equal to 1 basically means a column wise. Okay. Now, and whatever it will be dropped, all of the data will be stored in the form into the variable x. Okay, there is a variable x. After that, into the variable y, I'm converting, basically not converting, I am basically saving df cost per month of premium kind of data into the variable y. So we have understood these two lines, right? What exactly it is. So now I have made my x variable, which contains 5 columns because 2 columns I have dropped, right? And y column, which contains only one data frame or one column only. Okay, this is my target variable as well. This is my target variable. Okay, target variable. We know that, right? What exactly the target variable is? Or this is my independent variable. Independent variable. Independent variable, we know that, right? We have talked about already independent variable and dependent variable. Okay. So now we know that we need to use train test split. We have to pass x comma y. These are the two columns we have to pass, right? And test size. Test size is 30. 30 basically means a 30% of a ratio it will be split my data. That means 70% data will be used for my training purpose. We know that, right? Whatever that machine learning model I'm going to use, I need to train that machine learning model onto my data set, whatever that data set I have. Okay, so I'm going to take a test size is 30%. That means 70% data will be used for training part and 30% data for be used for testing part. Okay, random state is to basically randomize your data. Simple. And here I'm going to calling a linear regression model. Linear regression because we have a linear data. So here I'm going to basically calling a linear regression model and within a variable lm, whatever that variable name we can pass. And I'm going to fit lm.fit. I'm going to fit my linear regression model onto my training data. We know that, right? We have to train our machine learning model onto my training data only. That is why I'm passing x train and comma y train, right? In this way. After that, I have run this one. After that, if I have run this, so my model has been trained now. My model has been trained now. After that, we know that, right? Y is equal to mx plus c. We know that the formula of linear regression is y is equal to mx plus c, right? What exactly m is? What exactly m is? Why, like we know that y is target variable. There is a formula. Try to understand linear regression in the format of formula only. Y is equal to mx plus c. And what exactly m, not m, what exactly y is in y is equal to mx plus c. Y is a target variable, right? M is an intercept. Yes, some of us saying M is an intercept, and x, what is x in my y is equal to mx plus c? What is my x? Can anyone tell me what is my x in variable in y is equal to mx plus c? C is an coefficient, okay. And what is an x? Basically, let me write the formula as well. The formula is y is equal to mx plus c. In this is a formula of linear regression. Y is my target variable, and what is an x is my intercept. Yes, intercept. You can say the slope as well, right? And c is my coefficient, or you can, other than coefficient, you can write independent variable as well, right? Independent variable. Or some of you are saying c is my coefficient. Yes, some of us c is an coefficient. Yes. So this is my variable, right? Pretty much simple. So intercept, basically what exactly the intercept is, we know that, right? Linear regression makes a best fit line. Let me just write a function, let me just make a chart. We know that what exactly mx plus c is. What exactly linear regression is? Linear regression tries to make a best fit line. Again, I'm explaining again, guys, right? Just take care, just to basically focus one more minute. Y is equal to mx plus c is nothing but, that means linear regression is nothing but it tries to make a best fit line throughout your data points. So these are the data points I have into my from my side. So linear regression tries to make a best fit line. So this is the best fit line it tries to make throughout my data points. This is a linear regression, pretty much simple, right? Getting at point, right, guys? So linear regression is nothing but it will tries to make a best fit line throughout your data point. Simple. This is a linear regression with the help of this formula, y is equal to mx plus c. So this is my slope, you can say slope, right? This is my slope. Getting it, guys? So these are the stuff we have talked about, we are read in 10 12 standard as well, right? Some of you have seen. Okay, now, or if not, don't worry about it, we will discuss these things in depth as well, but just for now you have to understand linear regression is nothing but it tries to make a best fit line throughout your data point. Now, so we know that if you want to see the coefficient, what is the value of my coefficient throughout my data set? What is the intercept value? What is the intercept value? That means the m value, right? So here it is printing, okay? Here it is printing. Let me just write in this way. It is printing. Just write into another cell. That would be better for you. What is CF? This is my CF and this is my intercept value. So this is my intercept value. Don't this right now, don't take care about, don't too much focus about the values, right? What exactly the values is, it is coming from negative y. Don't take care about this one. Just try to understand the logic, right? What exactly, like how linear regression is working on the data set. Okay, now, so coefficient value, this one, this is the coefficient value we have. So that means the C value, coefficient value throughout my different columns. Why it is showing me 5 values, 1 value, second, 3, 4, 5, 5, 6, 3, 4, 5, 6, 6 values it is showing because we have a 6 features, right? And intercept value is -8 in this way. There is a value of intercept, that means the slope. Okay, you can say in this way. So this is a value. After that, we are just going to lm.predict. After that, we are going to use a lm.predict is a method which will predict, which will give you the prediction throughout our data points. So x underscore test is my data set, right? The 30% part. Yes, we have 6 features, right? I believe I have 6 features, right? Previously, yes. So now lm.predict x underscore test is my test data. Or not, yes, it is my test data. We have split our data set in the format of 30-70% of a ratio. 70% data we have used for training, right? And 30% data we are going to use for testing. Okay, so x underscore test basically used for prediction. After that, I'm going to store everything. The actual data is nothing but y underscore test is my actual data, right? Where we have split our data set. And PR, what exactly PR is? PR is nothing but the predicted one. Okay, I'm going to make a data frame to basically see the values. To see the values. So see, this is my actual value and this is my prediction value. This is my actual value, this is my prediction value. This is my actual value, this is my prediction value. The same values we have. Can anyone tell me why I'm getting a same values, the actual value and the prediction value? Can anyone tell me why we are getting a same values, the actual one and prediction one? Why my model is performing a same values? Why it is predicting a same values? There is no slightly change. Can anyone tell me why is it so? Any one of you? Can anyone tell me, guys, why I am getting a same values in predictions as the actual? Anyone? Guys, be interactive. Try to give an answer. What, don't care about that. It being a wrong or right. Don't worry about that. Okay, don't worry. I'll let you know. So I am getting the same values of predictions as actual because of I have a less data set. We have only, okay, some of you are saying answers. Yes, it is more accurate. Some of us are saying no idea. Don't worry about that because we have a less data set. There are two reasons. First of all, like model performance is good. Yes, model performance is good. Okay, because the data we put in the machine is more accurate. You can say the accurate meaning is to basically we have a less data. We have a data only 65 records. We have a data only for 65 records, right? And if I have 65 records and I have 65 records, I have split in the part of 70%. At that time, understand in this way, I have a 65 records. In this 65, 70% records I have been used for training part. Maybe because of mathematics from the method. Because of the mathematic from both methods. Yes, less data is more accurate. You can say no, not like this. Less data is more accurate. No, the meaning is to basically we have a less data and our machine learning model basically overfitting on that data set, right? Yes, more it will be accurate, right? Because a limitation of my machine learning model is more, and I'm just passing into a like a very small data, 65 records of a data. So my model has been trained so accurately. My machine learning model trained so accurately on that data set. That is why it's called overfitting problem as well, right? Because my model is performing well. Again, my model is performing well on my training data, but it is not performing well on the test data. That is called overfitting problem as well, right? Let's just check the accuracy as well. You can see the accuracy of my training data is 800% and the test accuracy is also 100%. That cannot be possible, right? In a real world, that cannot be possible. Accuracy cannot be 100%, right? That is why it's called overfitting problem as well, right? In this way as well. So my model has been trained so much accurate onto my training data. That is why I'm getting 100% of an accuracy. Getting it, guys, right? Everyone, are we good till now? Right, guys, are we good? Can anyone tell me? Okay, guys, be responsible. Please be comment in that one so I can get an idea. Okay, okay, guys, yes. So another method. So we have discussed this thing. Basically, we have trained a machine learning model, we have trained a linear regression model, and we have seen the actual value and the predictions value, and we can see, okay, my model is performing. You can say, okay, it's not performing well, but my model is performing. Okay, my model is performing in this way. Okay. Yes, it can be a good model. Yes, you can say in this way. Correct, guys. Yes. Yes, correct. Or it totally depends on the data set as well. Yes, but in the normal ways, yes, it could be a good model as well. Yes. Yes. So see, this is a scatter plot I have made. So see, this is my scatter plot. So see, I have trained my model. So see, here I have taken a basically x is, so here I'm taking a two models, two variables only. I'm taking a x variable or basic one onto my x data, onto my, you can say, the independent variable, and dependent variable I'm taking a standard ways. Normally I'm applying a linear regression model normally, not like this, not like this. Sklearn dot linear model import linear regression, not like this. I'm making this in this way only. I'm writing this way, another technique, right? From the SciPy imports stats, and stats dot linear regression is a model in SciPy as well. And I'm making a plot in this. You see, I made a function where I'm multiplying a slope. That means, you know that, right? Mx, this is my m x plus c, right? And I'm mapping those values in the form of list. My function multiply by x, and I'm making a scatter plot. You can see how much accurate it is, right? In this way, pretty much simple, guys, right? So this is another technique. You can say with the help of SciPy, we can use a linear regression as well, right? Not like with the help of Sklearn as well. As I told, Sklearn is a famous one, or like whatever that models we can use in machine learning model. Sklearn is a famous one, but we can use SciPy as well. Okay, pretty much simple till now. Now let's just move ahead. As I told, the main aim is to basically applying linear regression or another models to basically to show you how it works on the data. Main aim is to not to basically apply to get the good accuracy. No, that was a different part. Our main aim is to basically let us know how it is working on our data, right? Okay, okay, now guys, so now another technique, I'm just using this one. What a kind of another technique is another data we are using for to applying another model. So I'm applying a pandas, numpy, sklearn dot imported dataset. Python has a library sklearn which has a function dataset which contains already some dataset like a Boston or like an iris dataset as well. There's a normal dataset. In this one, I'm going to train my model, okay, to show how basically it will work. Model selection, importing a tree, okay, import a graph which to basically visualize the graph in the format of tree. Okay, now I'm just taking dataset dot load underscore iris within a variable iris. I'm just seeing the directory, whatever that directory I have into my this dataset, load iris dataset. This is a function. Load dataset dot load underscore iris is my function. So this function give you the whole dataset iris. Okay, and I'm making a data frame of iris data, and the column should be iris dot feature underscore names. So these are the techniques, or these are the method we have already in this dataset. That is why I'm just directly making a data frame in this way, right, guys? And after that, I'm taking a target variable. Iris dot target variable has already been in iris. That is why I'm not passing another single variable containing into a variable target. And df dot target dot apply iris target names, whatever that names we have into my target variable columns. And I'm going to store these numbers into my flower underscore spaces. And I'm printing the values of my target. So see, this is my dataset looks like. This is my dataset looks like. Don't worry about this. Not that much difficult to understand how do we did that. There is a simple one, load underscore iris. In real world scenarios as well, we don't need to use a load underscore iris. These are the not stuffs, right? Don't care about this one. Don't worry about this one. Main aim is to basically for today's one, we have to apply how to apply any machine learning model onto any kind of a data, right? These are tasks. So in real world scenarios as well, you will get these kind of a data. You will get it directly to the data. Your manager will give you the data in this format directly, whether it is cleaned or uncleaned, or you will get a data directly to the some resources. Okay, don't care about this. Don't worry about these kind of libraries. Okay, now let's just see that. So these kind of things, like here I'm going to filtering some of my records. So df dot target, wherever, as I told, right, I'm going to see the filtering. This is called a filtering. We have talked about there's a how to do the filtering in Python. Df dot target is my variable. Wherever it will be, it is equal to 0. I just want to see those names only. The data. If I just remove this, head is equal to 3. So these are the features it is not showing. What is not showing me? Because I need to run this one again. It is not showing me because I need to rerun this Jupyter file again. That is why it will show me, right? So I'm not going to run this one again. So now df dot target, wherever it will is equal to 1, I just want to see the variables. I just want to see the basically the column names, versicolor, whatever that flower, you can say flower classes we have. We have a multiple classes in our data set. Flower, versicolor, whatever that library, whatever that categories, or you can say whatever that classes we have for a flowers. Okay. So our main task is to basically start here only. What are the tasks? Okay, see, these are the variables I'm taking up for my independent variables. So see, sepal length, sepal width, sepal petal length, petal width, in this way. After that, seeing the target variable, right? So after that, I'm just seeing the shape. See, X shape is nothing but 150,4 and 150,1. Yes, we have a 3 classes in this one. Yes, there are 3 classes. Yes, 3 or 4, whatever it is, maybe there are 3 classes in our data set in this one. Okay, 0, 1 and 2 maybe. Yes. Now, so here our main task is to basically start from here, the machine learning part. So we have split our data set into the form of X and Y. After that, we have to split our data set into the form of to prepare our data set for a machine learning model. The test size should be 20%. We can take a test size based on our requirement. Some of them basically use for 60-40% as well, or it totally depends on a business as well. What's the requirement of a business, right? But in generic way, in basically you can do the standards way, we have to split our data set in the form of 70-30 or 80-20 most of the time, right? In normal case, but it depends on a business to business. Now I'm going to split my data set X, Y. Text size should be 0.2. Random state is equal to 1. We can take it anything. We can pass here 42 to or 0. You can pass it up to basically randomize your data. Now to see the dimensions, x underscore train dot shape, the shape of test data, train data, test data, the shape like this 120. The training part, right? 80%. It will basically split our data set in the form of 80%. It is 80%, 20% is here, 80% is here, 20% is here, right? Pretty much simple. Because see, it is don't necessary you need to put 42 or 1 or 0, because there's some random variable or random number. Wherever the random state is nothing but it will basically behind whatever that model you are using, behind it there's some randomization of your data set throughout your machine learning model will be happen. It will be randomize your data, right? It will be randomize your data. If you are passing 0, 42, 0, it don't care about it. By default it works. If you have just passing 1 here, at that time it will randomize your data the same way if you are passing a 42 as well, the same one. There's no difference between them. You can say you can pass 0 as well in this. Okay. Yes, we have to learn a mathematical intuitions about these algorithms, because of if you want to clear any kind of an interview, at that time interviewer will not going to ask you how these kind of models works, right? Behind it, it may be ask you, okay, how it works mathematically, sorry, right? Because these are the steps what I'm going to explain to you. These are the steps basically helpful for you to apply these models, any kind of a model or any kind of a data, right? Because after, if you want to clear any kind of a model or any kind of an interview, at that time you need to understand the mathematical intuition for sure. Okay. Now I'm just explaining, I'm just importing a decision tree classifier, because we have a classification problem at that time. That is, I'm just using a decision tree classifier. After that, random state is equal to 1. Again, I'm just fitting it onto my train data. I have split my data into the format of 80-20 ratio, right? Now after that, I'm just seeing, okay, actual training example, versicolor. Here I have written, right, the iris dot target name. Don't care about this one. If just remove this one, it's not, it will basically confuse you. Okay, nothing more than that. Okay, that's great. If you know about some of the mathematical intuition, that's very nice, Reddy. Yes. So see, we have trained our decision tree model throughout our data set, right? A trained data. After that, I'm going to check the accuracy. My accuracy is nothing but a 96%. My accuracy is 96%. So what do you think? Is this sufficient for this data set? Is this sufficient for this data set, or should we need to improve the performance, or like with the help of you can say, what is the technique where we improve the performance of a model, guys? Should we use that technique as well? If I'm getting a 96% of an accuracy, what do you think? Okay, yes, we can improve that thing as well, but it depends, because we don't know our data set. We don't know our data set. So what do you think? So maybe this 96% accuracy would be good, right? Or maybe this can be this would be higher as well, or this should be lesser as well. We can use a hyperparameter tuning to improve the model performance, but it depends on a model, not model. It depends on the data, because we don't know about a data set in this one, Boston, or like not Boston, Iris dataset, whatever it is, right? But we can improve the dataset as well. Okay. Yes. Now you can say it is sufficient. This is much more sufficient. We are much more sufficient. After that, tree dot plot tree CLS. CLS is nothing but this is my decision tree. After that, how it is splitting. We know that, right? Yesterday we have talked about decision tree. How decision tree, some of you like asked yesterday as well, how decision tree basically split the features. How decision tree basically split the features. Can anyone tell me how decision tree basically split the feature? If I'm going to train my decision tree onto my data set, at that time, how decision tree basically split each and every feature? What is the technique basically? How will be split? Can anyone tell me? Yesterday we have discussed that thing. What kind of technique basically used for this? Anyone? What's the technique decision tree use for splitting the features? How decision tree split the feature? Entropy, yes. Entropy, Gini index, right? These are the techniques basically. Yes, Gini index, entropy. Yes. So now with the help of tree.plot_tree, we basically build the decision tree. How? Just see in this way. Just seeing this. You see, it is splitting my data set 0.8%, like 0.8. Gini index is 0.66, the first feature. After this, it has split the data. Gini is 0.0, sample is 39. Here my sample is 120, right? Here my Gini index is 0.49. So basically it is splitted my data set in the form of, with the help of, yes, in the help of information gain, determination, yes, Gini impurity or entropy. With the help of these three techniques, decision tree basically split my data set. But decision tree can be basically, it can be built. This chart would be helpful for if we have a smaller data set. This chart would be helpful, but if we have a large data set, this chart cannot be helpful, right? We cannot see each and every node, right? At that time, random forest would be used. Okay, now let's just see. Again, I'm just using a Boston data set as well. The data set dot load underscore Boston, like the way we did for load Iris as well, like the same thing we are just doing for load underscore Boston as well. Just don't care about this, how the data is generating, right? Data frame, I'm just making a data frame. After the data frame, my data set looks in this way. My data set looks like this. Okay, after this, I have basically splitted my data set within a variable X and then Y. I'm just going to see the shape of my data set. After that, I'm going to split my data set in the form of 80-20%, right? Here I have seen the shape of my data for X train, X test, Y train, Y test. After that, decision tree regressor. I'm just using a decision tree regressor, not a classification. Can anyone tell me why I'm using a regressor here, not a classification problem? Can anyone tell me why I'm using a decision tree regressor? not a decision tree classifier. Can anyone? Yes, guys. Can anyone tell me? Pricing as well, yes, because we have a target variable which contains a continuous data, right? 18.9, 13.4, 17.8. In this way, data is continuous. Yes, data is continuous. Not data is continuous. Our target variable is continuous, not data. We don't care about the whole data. We just more take care about the target. Target variable is continuous. On the previous thing, on the previous data set, the iris one, we have a classes, right? A versicolor iris data set, right? We have a classes. That is why it was been categorical data. That means it is a classification problem. But here in this we have a target variable is continuous. That is why it is a regression problem. So we can use a regression, linear regression as well, or we can use another thing as well. We can use decision tree regressor as well for this. Right, and right, guys, understood? Okay, okay, guys, nice. After that, maximum depth of a tree, I'm just passing here 3. I just want to make my decision tree, the depth should be 3 only. I cannot, basically I'm just basically uh fixing my decision tree depth is 3, right? This is called a pruning technique as well. After making a decision tree, we can prune our decision tree, basically just cut some leaves. Okay, random state is 1. We can improve the model, we can improve. So this is called a hyperparameter tuning as well, right? These are the parameters we can use for our model, improving a model performance. Yes, we are predicting a price. Yes, predicting a price. Yes, there is a called continuous variable. Yes, guys. After that, decision tree classifier, I'm going to fit it onto my training data set. After this, I'm just making a data frame of my predicted values. So see, I'm making a data frame of my predicted values. I'm making a data frame of my predicted target variable, whatever it is. After that, you can see, I'm just going to concatenate. Someone of you have asked on that about a concatenation as well. So see, like this, we need to concatenate pd.concat. After the concatenation, we have to pass the axis. So see, axis is equal to 1. I want to concatenate to data frame from the axis is equal to 1. That means a column wise. Let me just write column wise, right? In this way. So after that, I'm going to make a concatenation. I'm just going to transform these. You can see the target variable is not target. Yes, target is 28.20, but it is predicting 26.83, right? Merging, you can say the merging. Yes, 23.90, 26.34. This is called a prediction value, right? So my model is performing, right? And the accuracy is we are getting 66%. We are getting an accuracy 66%. That means our model basically 66% would be good, you can say, right? So you can see in this way, okay, my model is performing good in this way, you can say, right? 16, previously the target variable is 16, but model is performing 17%, or you can say 17 variable or 17 value. Okay, Boston data set, that means a price of a house, you can say in this way, you can understand in this way. The house of a price in my data set, it is 16, you can say 16 lakh, but this should be 17 lakh based on my decision tree model, right, guys? After that, we have seen the score, right? We have seen the score, like how model is performing 66%, right? And we have made a plot, tree dot plot. If an accuracy is 60, less than 60%, then we need to think it of more. We need to improve the model performance. If I'm getting a less score, or you can say that's less accuracy, if I'm getting, if my data set is much more sufficient, you can, sufficient basically means I have some of the records like 2000, 5000, 22,000, whatever, right? Or if I'm getting a 60% of an accuracy or less than 60%, I need to use a hyperparameter tuning to improving a model performance, right, guys? After that, I'm going to plot my decision tree, right? Tree dot plot underscore tree and decision tree. After this, we can see. So this is my decision tree. This is my decision tree made upon, right? Squared error. We know that, right? Why it is showing me squared error? Previously, it is showing me on iris data, it is showing me Gini index value, right? Gini index, entropy. But why here it is showing me squared values? Can you tell me squared value or R squared values? When do we use these kind of matrices? Anyone? Can you tell me why it is showing me squared values? Anyone of you? Anyone? Why it is showing me squared error values previously? Yes, this is a regression problem. Yes, this is a regression problem. Previously, we are solving a classification problem. That is why it is showing me the values of Gini index entropy in this way, right? Yes. So this is how we can make a machine learning model based on our data set. And what are the hyperparameter tuning we can do? Any kind of machine learning model, just put your cursor there. Whatever that model you are going to use, just put your cursor there and just type a shift tab. So in this one, it will show you, okay, what are the parameters do we have? Criterion is by default, it is squared error, right? But we can improve this one. Split it is best. Maximum depth is none by default. Minimum sample is 2. Minimum weight fraction this way, right? These are the multiple parameters. Criterion, what are those different parameters we have? Absolute error, right? Or Fridgman mean square error, Fridgman mean square error, Poisson, right? But by default it is squared error, right? By these kind of parameters we can do the hyperparameter tuning and we can improve the model performance. After that, checking a model performance, we can do like you can say means like R squared value, mean squared value, right? F1 score, these kind of things. Confusion metric, these are the stuffs. Yes, regression, we have a squared errors by default. By default, we have got the squared errors, but we can change into a Fridgman mean squared error or absolute error as well, or Poisson techniques as well. Yes, by default, it is a squared error. Are we good till now, guys, right? How do we apply any kind of a data to any kind of machine learning model? We have talked about when we have read decision tree, random forest, and we have talked about a linear regression as well, right? Are we good till now, right, guys? Any kind of a questions you can ask? You are such a great audience. So this is the last today for our workshop, guys, right? If you have any kind of a question, you can ask, right? And again, happy Holi for you, right, everyone? It's the whole day we have a Holi, so you can, yes, you can ask any kind of question, guys, related to what we have discussed so far. You can ask me if you have. But this is how we can apply any kind of a model to any kind of a data. Anything you can ask, right, guys, related to what we have discussed so far. So see, for the practice purpose, I would suggest not to any kind of a data. Just go, just basically, you can say, for practice purpose, just go for, you can say there are some platforms where you can pick the data with using APIs and all that, right? Just go to GitHub as well. You will find some of the good data set and you can apply those like models, whatever it is, right? But for practice purpose, there is no such data set for practice. You can run any kind of a model to whatever that data you have. You can make your own data set as well, right? You can make up. Yes, for sure. In future, reinforcement learning would be delivered from myself. Yes, guys, correct. But now we are more focused about supervised, unsupervised, and all that stuffs. Yes, adjusted R square would be used for, we can use that thing as well. Yes. Yes, yes, you can ask, guys. Happy Holi, guys. Happy Holi. Happy Holi for everyone. So we have a last day, guys, right? Any person, if has any kind of a doubt, you can ask. And then let's just wind up the session. Such a great audience you peoples are. Anything else, guys? Are we good till now? Okay, the skills basically, okay, let's just, okay. About interview questions, so see, I feel like related to interview questions and all that, the required skills I feel like I for sure Python, SQL Server or visualization tool, if you had, that would be plus point, right? Python, SQL Server, Power BI or whatever it is, Tableau, and statistics. There are four essential tools you need to be good at, right? Whether you are going to the fresher level or whether you are going for an experience level as well. So these are the four main techniques you need to know about. Related to interview question, just read machine learning or like for sure machine learning, NLP, deep learning, if you have any, if you have done any kind of project. But related to interview questions, you need to be good at whatever that techniques you have read till now, you have learned till now, whatever that techniques, just read those techniques in depth. In depth basically means, let's suppose you are reading any kind of machine learning model, you need to be good at that technique, how it works, if you did something, if you did some slightly change on that machine learning model, what will happen, how to improve, these kind of stuff related to the interview questions basically come with that as well, with the from these techniques as well. Okay, okay, analytics, okay. Related to certificate, you need to ask with the team, guys. For sure after the session you will get the certificate, but you need to ask them about related to certificate. And related to data analyst, okay, so as I said, if you want to crack any kind of data analyst, data scientist, data engineering kind of related interviews, you need to be more focused about your techniques or your skills. Basically skills are much more important, right? Just work on your skills, focus on your skills, Python, machine learning, just basically try to make a projects, right? Just try to make a good projects, put your good projects into your resume. At that time it would be good, right? Your resume will be shortlisted and then you can crack any kind of an interview, right? Whatever it is not mandatory you can clear, and Tiger Analytics, EXL services, many more companies you like basically we are basically hiring for data analysts, data scientists, right? Yes, we have Python jobs, data analyst, data scientist job for Accenture as well. Yes, yes, we'll share the Jupyter notebook, guys. Yes, thank you, guys. Thank you. Related to good project ideas, I can say, you can say not to basically project ideas, just be basically more focused about the on which field you are making a project, like whether it is NLP, whether it is machine learning, whether it is deep learning. Just try to make your project in these technique as well, right? If you are going to NLP, they are just build a chat bot, right? Just build a topic modeling, just work on some topic modeling projects, right? In this way, whatever that model or like whatever that you will obviously, whatever that project you did in machine learning in or in NLP, just put your best project into your resume. At that time your profile will be shortlisted, right? There are multiple projects, like I cannot tell them directly what are the good projects. There are more like n number of projects you can work it on. Yes, if you have if you learn R, that would be best. Really, like with the Python as well. If you learn R as well, that would be best. Yes. Machine learning project, there are multiple projects, right? Like I cannot tell you directly what are the machine learning projects we have, right? In machine learning, we have to train a model and we have to predict a classification problem. Just try to uh, pick a project concisely, like classification problem. Just pick a classification problem or real world problems, right? Just try to figure out a actual problem where basically peoples are stucking, right? Just try to solve those problems with the help of machine learning model, Python, whatever it is, right? Whatever that model. Yes, R language would be good for statistical modeling or statistical analysis. Yes, if you learn R, that would be good as well. Yes. Yes, these are the companies. You can say Excel, Tiger. These are the companies basically hiring much more because of there are multiple projects related to data science, because companies are moving towards your data science. Yes, that is why they are hiring for data analysts, data scientists as well, right? So it depends, Tableau or Power BI. Basically, it depends on company to companies, right? Some companies are asking about Power BI or Tableau, but if you learned any one of you, that would be good for any company. If you have learned Power BI, at that time company will hire you if the requirement is Tableau only, because they know that if a person knows about Power BI, a person can be within a week can learn a Tableau as well. There's not that much difficult for that person, right? Just learn anything, whatever that you will comfortable. The related to certificates, you need to ask with them the team, right guys? Or definitely you will get your certificate after the session. Just try to contact to the basically to the team, right? And that the team will let you know exactly. Yes, Tableau would be good, guys. Yes, I think guys we are good till now, right? We don't have like more questions, I believe. Yes, you will get the goodies. Who basically perform well on the quizzes, they will get a goodies as well. Yes. Thank you everyone, thank you so much. Thanks for joining, thanks for connecting. Happy Holi again for everyone. It's a good audience you are, guys. Thank you everyone, thanks for connecting. Assignment link you will get for sure. You will get an assignment link soon. Thank you guys, thank you. Bye bye. Yes, we'll after the session we will get the assignment as well. Yes, after the quiz. Yes, for sure. Thank you everyone, thank you. Thank you, Reddy. I believe it's a Reddy. It's a long name. Okay, that's a Reddy. Yes, I'm just saying Reddy only. Thank you, guys. Bye bye. Take care. Bye bye.